Okay, good morning, geometry class. Welcome to this morning's lecture. It's going to be a little bit weird for me talking to a computer screen, so please forgive any hiccups along the way. Today we are going to be doing lesson 10.5. 2 weeks ago we started chapter 10 with 10.1 and 10.2. We are going to skip 10.3 and 10.4 so we can catch up. All right, so skipping 10.3 and 10.4 content. That content was analytic proofs, which I think is not as important as the other content of chapter 10. Now chapter 10.5 is picking up where 10.2 left off. So if you had a hard time with that content, then email me early in the week. I can try to help you along, try to explain it again, maybe make a video for you. We just need to understand it pretty well before we get moving on, otherwise you might be lost, because we are going to continue using coordinate systems, and today we're going to be talking about the equation of a line, a straight line. Test 9 is going to be sent out this week, as well as homework for 10.5. If you want to see your graded homework for chapter 9, email me and say that you want it, and then I will send it to you. Otherwise, I'm just going to give it to you the next time that we meet in class. So, let's begin. So previously we learned that we can graph equations. An equation like 2x plus 3y equals 6. We learned that we can graph this, right? We can do that by plugging 0 in for x and discovering what y is, and then plugging 0 in for y and discovering what x is. That gives us an ordered pair, 2 points on a line. Those 2 points can be connected to form a line. Now we're going to learn, this kind of equation has the general form of x, a being a constant, plus b, y, b being a constant, is equal to c. Now, when we look at this, we can't immediately tell much about the line. We don't know what direction it's going in. We don't know if it's really steep or if it's really shallow. So we want to be able to convert this into a form that we can easily read and immediately know stuff about it. So that form is called the slope-intercept form. So slope-intercept, y is equal to mx plus b. Y is the same, x is the same. In chapter 10.2, we introduced m as the slope of the line. You can discover it if you have 2 points. Most of the time in this chapter, it will be given to you. And b is the y-intercept. I'm not going to write that whole thing out. Drawing with a mouse is kind of difficult, so I apologize for any poor penmanship that you're going to see here. We're going to talk more about what the y-intercept is and what the slope is, but first we're going to get some practice with converting between the two formats, these two formats right here. So if you want to follow along, this is example 1 in your book. So we have in the general form, the equation 4x minus 12y is equal to 60. And we want to convert that into y equals mx plus b. So this m is a constant. This b is a constant. They are not variables. Don't freak out. We're going to begin to solve this by getting y on its own, right? We see y is on its own over here. We want y to be on its own over here. So we're going to have a negative 12y is equal to the 60 minus 4x, because we're subtracting 4x from both sides of the equation. Now, we can divide both sides by negative 12 to get the y by itself, right? And I'm going to go ahead and switch these two dudes right here. So that's negative 4x plus 60. Each of these over 12. Y is equal to that. And we can simplify this to, as a negative 12, my apologies. We can simplify this right here. The two negatives become a positive. 4/12 is equivalent to 1/3. So this is y is equal to 1/3 x minus 60 over negative 12 is negative 5. So y, this equation up here in the general form, becomes y equals 1/3 x minus 5 in the slope-intercept form. Converting between the two is just algebra, and it's not tough algebra either. This is stuff that you guys have done, I think. So we can identify that in this new form, this term right here, this 1/3, is our m, and this negative 5 right here, this is our b. All right, so if you were having trouble figuring out what m was and what b was, this is it right here. We are going to do a second example. However, this time we are going to be taking the slope-intercept form, and we're going to be converting it to the general form just for some practice. Now, we're given some information. We're told that our slope m is negative 2/3. So since this is slope-intercept form, we know that y is going to be on its own. M is negative 2/3, so we're going to write that in. We know that m sits right beside x, so if we're given an m, we just put it right in front of our x. Now we're going to add b. B is our y-intercept. Remember that. So our y-intercept, our b term, is negative 2. So that's going to be adding a minus 2. This is interpreting example 2, what we're given to point slope form. So we want to convert this to where we have a constant on one side on its own, and our two variables on the other side. So we're going to add 2/3 x to this side over here. That's going to give us y plus 2/3 x is equal to negative 2. Now, this 2/3 can be kind of hard to work with mathematically. It's not the prettiest thing, so we are going to make it easier by multiplying the entire equation by 3. That will get rid of this over 3 term right here. So if we multiply the whole thing by 3, we're going to have 3 times y plus 3 times 2 is 6, or I guess actually the 3's would just cancel out. The 3 multiplied by the 2 over 3, 3 cancels out. That gives us a 2y is equal to a negative 2 times 3 is 6. Now, this is an acceptable answer. However, if you were to take this negative sign and make it positive and make these two terms negative, that is also acceptable. Now that we have gone back and forth between the two forms, let's see why the slope-intercept form is even useful. Okay, So we're going to go to example 3 in your book. I have drawn a coordinate sheet for us. So let's see how it works. Now, the slope determines how steep the line is. So let's see, a really large slope is a very steep line, where a small slope is a shallow line. If that slope is positive, the line will be going this way. It will be going up as x increases, y increases. If the slope is negative, the line will be going this way, down, as x increases, y decreases. So let's do example 3. We have that 1/2 x plus y is equal to 3. For this to be usable, we want to convert it to slope-intercept format. So we're going to subtract 1/2 x from both sides, giving us that y is equal to a negative 1/2 x plus 3. Let's identify what we have in this equation. Our m term is negative 1/2. That is our m. And our b term is 3. So we want to find the first point. The y-intercept is where the line crosses the y-axis. So remember, this horizontal axis right here is the x-axis, with this direction being positive. This axis right here is the y-axis, with this direction being positive. And what the b term tells us in slope-intercept format, please ignore that, is that the line crosses the y-axis at y equals 3. So when x is equal to 0, y is equal to 3. And we can see that in our equation. So if we were to plug 0 in for x right here, this whole term would go away. We would be left with y equals 3. So we see that when x is 0, y is 3. And this is our first point. Now, the slope is going to tell us where our second point is going to be, which will allow us to make a line. Now, what we could do is we could plug 1 in for x and see what y equals. So if we did that, let's say we plug 1 in for x, that means y is equal to negative 1/2 plus 3. That means y is going to be equal to 2.5, or 2 and 1/2. That means when x is 1, y is going to equal right here 2.5. But we can also, so let's see, when x is 2, that means this term is minus 1, this term is 3. When x is 2, y is equal to 2 as well. That gives us this straight line right here. But we could have already determined, we see that this line is going downward, y is going down as x increases. We knew that because the slope is negative. What the slope tells us is that for every one change in x, y will change by this number amount. So every time x goes up by 1, y goes down by 1/2. And we can see that right here. When x increased by 1 unit, y went down by 1/2 a unit. When x increased 1 more unit, y went down by another 1/2 unit. So that means if we had an equation of y is equal to, let's say, 3x minus 1, our 1 is the y-intercept. That means when x is 0, y is equal to -1. And when x changes by 1, y changes by 3 because our m is 3. So when x changes by 1, y goes up 1, 2, 3 right here. And it continues. When x goes up by 1 again, y goes up by 1, 2, 3 up here. So now we can draw that line right through there. That's pretty awful. Right there. And we have another line right here. And this line continues on in this direction. That is how we can read the slope-intercept format. We can solve for it, yes, but we can also just look at it in this format to tell the information behind the line, what direction it's going in, where it crosses the y-axis, where it intercepts the y-axis. Okay, so now that we've learned those basics, we are going to talk about point-slope form. So, if we know, I have a gap in my notes. Let's see. Okay, I think what I would like to do instead, and I apologize, is I would like to quickly do example 5. I did not write that in my notes. I missed it completely, but I think it's an important example for us to do. So let's work on, example 5. In example 5, we want to find an equation for, no, we're talking about point slope. I'm sorry, yeah, I made a mistake. We are talking about point slope form. Yeah, this is on page 466 of the textbook, point slope form of a line. If we know our slope, m, so if we have m and we know a point that is not the y-intercept, so if we have an ordered pair, if we have an ordered pair of coordinates, slope and an ordered pair, we can determine the equation for a line. Now, we can do this with a slope in one set of coordinates. We can also do this with two sets of coordinates, and we are going to see both. So, on page 467, we have theorem 10.5.2, and it's going to give us an equation. It's going to look very similar, that y minus y1 is equal to m multiplied by the quantity x minus x1. So, with this equation, in the problem you will be given y1, you will be given m, and you'll be given x1, because x1 and y1 are the point that you're given, m is the slope. Alright, so let's do an example really quick. We want to find the equation in both general and point slope form. This is example 4 for a line that has a slope m of 2 and it has the point x1 and y1 will be -1 and 3. With this information, we can plug it into this equation up here and get what we need. So our y1 is 3. Can you guys see that? Our y1 term is 3 over here, so we're going to have y minus 3 is equal to the number 2, which is our m, our slope, multiplied by the quantity x, which is a variable, minus x1. x1 is a negative 1, so if we're subtracting a negative 1, it's going to become positive 1. Now, this isn't the official point slope format, right? What we want is y is equal to mx plus b, and we also want to find the general form of ax plus by equals c. We want both of these. So we're pretty close to this form already. All we need to do is multiply this 2 through this quantity right here. That's going to give us that y minus 3 is equal to 2x plus 2. Now we want to put this 3 on this side. When we add 3 to both sides of the equations, we can't add 2x and 3, so that's going to stay the same, but we can add 3 and 2, and that's going to become 5. And that looks a lot like this form right here. That is our slope, or our slope-intercept form. So part 1 of this example is finished, but now we want to convert it to this form right here, and we have done that. That's what we just did not too long ago. Okay, so to do that, we are going to get both of our variables on the same side of the equation. That means we are subtracting 2x. So our minus 2x plus y is going to equal positive 5. We don't have any fractions, so this equation is good. Another acceptable answer would have been 2x minus y is equal to negative 5. These are equivalent. Okay, so let's say we weren't given m. Let's say all we were given, this is example 5. So example 5, let's say that all we're given is 2 points. So those points are going to be minus 1, 2, and 4, 1. Before we begin, we want to determine one of these as our x1, y1 from before. Because remember, x1, y1 is going to go into this equation right here. It doesn't matter which one, we just have to pick one. So we're going to go ahead and say that x1, y1 is going to be equal to this set of coordinates right here. Given two sets of coordinates, we can find the slope. And we did that in 10.2, I believe. It may have been 10.1, I can't remember. Let's go ahead and define this one as x2, y2. And if you remember, the equation for m was the quantity y2 minus y1 divided by x2 minus x1. So we can find the slope given these two sets of coordinates. We just have to plug it in. So our y2 is over here. It's this one term. So y2 is 1. We're going to subtract from that our y1 term, which is a 2. And we're going to divide that by our x2 term. x2 is 4 minus our x1 term. x1 is negative 1. That makes this minus a plus 1. This is going to give us 1 minus 2 is negative 1. 4 plus 1 is 5. That means our m is negative 1 over 5. Okay, and to turn this into the equation, right? Our equation was y minus y1 is equal to m times the quantity x minus x1. We're going to start plugging stuff in because we have this, now we have this, or we had this, now we have this. So that means that y minus y1 is 2, is going to equal negative 1/5 multiplied by x minus our x1 term, which is going to be minus a minus 1. That makes it positive 1. Now, our equation would have come out to be the same if we had used this term, and you can do that on your own if you're not convinced. You can check it out for yourself. I'm not going to save the time. Let's simplify this into the form that we are most familiar with. So we're going to distribute the negative 1/5 out into this term. That's going to give us minus 1/5 x minus 1/5. That is equal to y minus 2. Now that we're going to add 2 to both sides, that's going to give us y is equal to minus 1/5 x 2 plus 1/5. That's plus what? That's 1 4/5. So it's like 9/5. Yeah. So our final answer, converting these two sets of coordinates, these two ordered pairs, into an equation is y equals negative 1/5 x plus 9/5. Okay, now that we know how to use point slope form, I'm going to skip example 6 in the textbook, and I'm going to go to solving systems of equations with example 7 on page 468. So let's make a new tab. In earlier chapters, you guys should have learned how to solve a system of equations. To remind you, a system of equations is just two different equations, each one with an x term and each one with a y term. But now we can look at it a little bit differently. So we know that each of these equations can be drawn as a line. And sometimes those two lines are going to intersect. Now, if it's not always possible, there won't always be a solution, but most of the time there will be a single point where these two lines intersect. So let's say this line right here looked kind of like this on the coordinate system, and this line right here might look kind of like this. We're going to learn how to find exactly where they intersect. We're going to erase this quickly. So let's do that in example 7. First, we're going to do it algebraically. We're also later going to do it graphically, and then finally we're going to do it with substitution. And I don't know how many of these methods are new to you. I'm pretty sure you've done it algebraically before. So we're going to take this system of equations right here. Now you should have learned that in order to solve this, we want to make one of these terms similar. Now, because we want to make one of them go away, right? Now, if we were to take 2y minus y, that would leave us with 1y. But if we were to multiply this entire lower equation by 2, that would give us 2y minus 2y equaling 0, leaving us with only an x term. So we are going to convert this lower equation by multiplying it by 2. That would give us 4x minus 2y is equal to 14. And now we're going to add. I'm going to add these two together. So let's go ahead and stack them on top of each other to make it easier to follow. This is not a method I learned when I was taught this, so I'm tripping over my words a little bit. But you guys should have learned this a couple weeks ago. I'm not sure exactly when. We're going to add these two together. So what that's going to give us is x plus 4x is 5x. 2y plus negative 2y is 0. That's going to be plus 0. And then 6 plus 14 is equal to 20. So that gives us that 5x is equal to 20. If we divide by 5, x is going to equal 4. So our x coordinate is going to be 4. And to find our y coordinate, we just have to go back to one of these equations and plug 4 in. So let's say for this one right here, we plug 4 into x. We subtract 4 from both sides. Let's just write it out for clarity. We plug 4 in for x. We subtract 4 from both sides. We divide both sides by 2. That gives us that y is equal to 1. We could have found that y is equal to 1 on this equation too by plugging in for 4. So that means our other point, our other y coordinate is 1, meaning that these two lines cross at the point 4, 1. X equals 4, y equals 1. So that was example 7 over here. Now we want to do that by graphing lines. So this example is going to take a little bit longer, but it is another valid way of doing things. So remember, 4, 1 is where the 2 cross. We're going to use the exact same equations and see if we can get the same answer. So our system of equations is x plus 2y equals 6. My phone has been going off on silent almost the entire time, which is very distracting to me, and I apologize. I don't know who's talking right now, but they have a lot to say. Okay, so we're going to graph these. And we're going to start by converting these to the slope-intercept format that we learned earlier. So let's go ahead and call this equation 1. It's a terrible 1. Equation 1 and equation 2. So for equation 1, let's convert it. We're going to have that 2y is equal to negative x plus 6. Now we're going to divide both sides by 2, giving us that y is equal to negative 1/2 x plus 3. Now, we can remember that our line is going to be going downward because it has a negative sign. For every 1 change in x, our y is going to change by half. And we're going to cross the y-intercept at x equals 0, y equals 3. And we can draw that really quick. So we will draw some dash marks. And I've just realized this whole thing is grid paper and I could have been using the grid paper this whole time. Awesome. Alright. We're going to draw this equation 1. We know that it crosses the y-axis at x equals 3, so that's our point number 1. When y is equal to 0, let's see. Let's just see. If we plug 4 in for x, let's just say 4 is an easy one to do. That's going to give us 4 over 2. That's negative 2 plus 3. Negative 2 plus 3 is 1. That means when x is equal to 1, 2, 3, 4, y is going to equal 1 right here. We could have also gotten there by saying that as x changed by 1, y changes by 1/2 negatively. So we could have gone 1, y changes by 1/2, x changes by 1, y changes by 1/2, and so on, and gotten to this point. So that is going to give us one of our lines. And we believe that the other line is going to cross this at the point x equals 4, y equals 1. And we actually already have that right here. We believe it's going to cross at this point right here. Let's go ahead and convert the other equation to a more readable format. So now we're going to do equation number 2. We're going to see that negative y is equal to minus 2x plus 7. Now we're going to distribute this negative 1 across the whole equation, giving us that y is equal to positive 2x minus 7. So we have a negative y-intercept. That means when x is 0, y is negative 1, 2, 3, 4, 5, 6, 7. Y is going to be down here. And we know that when x changes by 1 unit, y will change by 2 units. So when x changes by 1, y changes by 2. When x changes by 1, y changes by 2. I'm going to go ahead and dot these. When x changes by 1, y changes by 2. When x changes by 1, y changes by 2. Puts us right on the intercept coordinate that we found just a minute ago. So let's draw that line right there. Because I didn't draw this graph very well, that's why these points don't quite touch. But we just graphically proved that these two lines intersect at this point of x is 4, y is 1. All right. We're going to prove that one more time, and this time we're going to do it by substituting. So, in example 9, we're going to take the same equation. This is example 9 on page 470 of your textbook. We have the same equations. X plus 2y is equal to 6, and that 2x minus y is equal to 7. Let's take one of these. Let's take equation number 1. And let's see, how does the textbook do it? Let's solve for y. So we were actually just doing that in the previous one by converting it to slope-intercept format. We're going to do it again. This time, the end result is going to be, the end process is going to be a little bit different. The result will be the same. So solving equation number 1 for y, we've done this. 2y is going to equal negative x plus 6. That means that y is going to equal minus 1/2 x plus 3. I've made a bit of a mess. Plus 3. Now we can take this term for y and plug it into our second equation. That is another way of solving for a system of equations, and I'm not sure if you've seen that before or not. So by plugging equation 1 into equation 2, we're going to see that 2x minus our new y is minus 1/2 x plus 3 quantity is going to equal 7. So remember that since this negative sign is in front right here, it has to carry through the entire quantity, because this is basically a -1 being multiplied by the whole thing. So that is going to equal 2x plus 1/2 x minus 3. This is where a lot of you will make mistakes, because that -1 has to be distributed across the entire quantity. Now, we are going to solve for x. We're going to add 3 to both sides, and we're going to go ahead and combine these two. That's going to give us that 2 and 1/2 x is equal to 10. Now, if we take x, or if we take 10 and divide it by 2.5, that means our x is going to equal 4. Now, this ought to start looking familiar to you, because on the other problems, our x-coordinate both times equaled 4. And now we're going to take 4 and we're going to plug it into either of these equations and find out what 1 is equal to. We've already done that when x is 4, 6 minus 4 is 2, 2 divided by 2 is 1, y is 1. So that was 3 different methods to solve for the same intersection between 2 different equations. 2 different equations that represent a line. I have skipped example 6 and example 10 in this lesson, but they should not be important to your homework. So, your homework assignment for this week is going to be 10.5, even problems through 30, and you will also receive the Chapter 9 test. And like I said, if you want any of your homework from Chapter 9 to help you study for the Chapter 9 test, I will send it to you, but you have to ask me by email. Otherwise, you will receive it in class the next time we meet. I believe that's everything. If you have any questions about any of the content, feel free to email me and I will get back to you as soon as I can. Thank you for watching.